With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, so we are given with a question which says a planet of mass capital M has two natural satellites with mass m1 and m2. The radii of their circular orbits are r1 and r2 respectively. So ignore the gravitational force between the satellites. Define v1, l1, k1 and t1 to be respectively the orbital speed, angular momentum, kinetic energy and time period of the revolution of satellite 1. V2, L2, K2 and T2 be corresponding quantities of satellite 2. Given the ratio of masses M1 by M2 as 2 and R1 by R2 as 1 by 4. So we need to match the ratio of list 1 and list 2. So let's begin. We have we have a planet. So let's try to visualize the given scenario first, then we will proceed. So let's suppose that this has been that planet given to us, and around this planet there are two satellites revolving. So we can make let's say first one is revolving in this orbit, and also there are two satellites. So let's say other one is revolving in this orbit. All right, so this is the planet been given to us, and there is one satellite. Let's suppose that this is satellite S1 and this is our satellite S2. All right, so radii is also been given to us. So let's mark the radii first, then we will mark. So let's suppose that this is the center. So from center the radii has been given. So let's say this is the first satellite radius. All right, so and the next is this been given to us as R2 and this is our R1. All right, so let's try to first visualize the given scenario. So we have been given with a planet. Let's say this is our planet, and there are two satellite that has been revolving around this planet. So let's say first one is revolving in this orbit, and also we have another which has been revolving. Let's suppose that this one is revolving in this orbit. All right, so there are two satellites. This is the planet. So from center we can mark the radius. So this one is having a radius of r1, and this orbit will be having a radius of r2, and here it is satellite 1, and here we are having satellite 2. All right, and this is our planet P. So we have been given that uh, v1 is the orbital speed. So orbital speed, or we can say the critical speed, the formula for that is given by orbital speed, that is VO is given by under root of gm upon r. All right, so from here we can see the orbital. This is nothing but, we will first write down all the formulas, then we will proceed. So this is orbital speed, or sometime it is also known as critical speed. All right, so this is the case. And second, this is L1. L1 is angular momentum. So angular momentum, we know that the formula is mvr. All right, and this is for, we will write it as for angular momentum. Since the orbits are rotating, so we have to consider angular momentum. Kinetic energy, we all know, half mv square. So half mv square, this is nothing but the kinetic energy. And finally we have time period. So time period taken by satellite to complete one is given by 2 pi r by v. So this is nothing but, this is the time period of satellite. So these all things we have studied. Just we have to now calculate the value. So for by definition we can say orbital speed is nothing but the minimum speed required by the satellite to complete the rotation around the planet. So this is given by this formula. So we can write, first we have to find the value of orbital speed v1 by v2. So we can say by formula, for first part we will say, let's write it as first. So v1 by v2 will be nothing but, as we can see, it is inverse relation and having a root. So we will write it as r2 by r1. So that comes out to be, it comes out to be the value as r2 by r1 is given to be as 4, 1 by r1 by r2 is given as 1 by 4, so it becomes 4. So the value of v1 by v2 comes out to be 2. Alright, so p is matching with this uh, third third number, that is values 2. And let's move on to the second part, that is L1 by L2. So for L1 by L2 we can write L1 by L2, as we can see it over here, it is MVR. So we can write it as the formula is M. So we have to consider all the values, that is M1 V1 R1 upon M2 V2 and R2. M1 and M2 ratio has been given to be as a, if we have a look over here, so it has been given 2. So 2 into V1 by V2 we have calculated it as again 2, and R1 by R2 is given to be as 4. So the value comes out to be 1. So it matches with second option. So we will write it as answer for Q is 2. And now kinetic energy we have to calculate. So we can write kinetic energy 1 upon kinetic energy 2 can be given as half mv square is the formula. So we will write m1 v1 square divided by m2 v2 square. Alright, so from here we can have m1 by m2 is 2 and v1 by v2 we have calculated as 2, and 2 square is 4, so this comes out to be 8. So this matches with R matches with the fourth list. And finally we have to calculate time period. So for time period we can write t1 by t2 as we have mentioned there. So it will be r1 by r2, as we can see both are in direct relation, and with velocity is inverse, so we will write v2 by v1. So this comes out to be r1 by r2 has been given to be as 1 by 4, and v2 by v1 will be 1 by 2. So this comes out to be 1 by 8. So this matches with this. So we can write p3 q2 and r4 and s1. So p3 q2 r4 s1. So correct option matching is option 2. So I hope you have understood the concept, and thank you for watching.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.